So now in this video, we're going to make the mechanical switch version of the digital NOT gate. And so we are going to control whether an LED is on or off based on the condition of two inputs. I'm actually going to be the input. These are mechanical switches. And so instead of high or low, we're going to focus on or off. So whether the LED is on or off, whether the switches are on or off. We'll talk about those coming up in a little bit. But to begin with, we have this resistor at the positive rail there. And so this is a 1 kilo ohm resistor to the positive rail. We're going to grab the LED here, and we need the anode, the long lead of the LED, towards the positive side of the circuit. Short lead the cathode. We're going to go down one row, which is, as you can see there, headed towards that jumper down there. Ultimately, that's where our electrical path is going to start. We're thinking of conventional current, positive, working our way to negative. And of course, if you're really obsessed with electron flow, you can think of electrons are going to flow through here, through the circuit, through the LED there, to positive. It doesn't really matter. The main takeaway is the cathode has to be more negative than the anode. And we're using a 1 kilo ohm resistor, 1000 ohm resistor. We have a 5 volt power supply. The LED is going to block about 2 volts. So it's going to make it so 2 volts of the power supply don't even count anymore. That will leave 3 volts across the resistor. 1 kilo ohm resistor will have 3 milliamps of current flowing through everything else, because the LED already blocked voltage, and then the resistor sets current. The switches set current by either being on or off. And so either they're blocking it all or letting it all pass through. So when they're letting it all pass through, then the resistor is the one that is setting the current. So we have the switch there. This is a push button switch, and I really like these little ones for the breadboard, but all the different push button switches I come across fit in the breadboard, but as you can see, not very well that way. And you don't want to insert it that way. You want to make sure and insert them in the direction where they line up pretty nicely. And they should pop in pretty nicely too. Their leads are shaped a bit different. Their pins, I should say, a bit different than the leads of the other component. So it may not be the best for the board, but they do fit, they do hold, and a good board probably won't get warped too much with them. So in any case, you may file them down or something, make them a little more breadboard friendly, but I really don't have a problem with these. So now, since we're going to make an AND gate, we actually need 2 switches. And so I am going to add a jumper first. And you may not be able to see me inserting it, but it is already picked to be the right length. So we got that spot there. Here you'll notice we got this jumper here, and I do have power applied. There's low risk of a short circuit, but of course there's always possibility of a short circuit when you're moving around a metal probe like this. So we have the jumper there. Here's a blank space, and then a jumper there. You'll notice there's a space in between the 2 pins of that one, and so we're going to use the same switch to make that connection. There we go. And that is it for our NOT gate. And the power supply, if you've been watching my recent videos, I'm using the same one, where if I bump it wrong, the wire coming in disconnects, or the plug or something. It's a little loose. So we may lose power once in a while when we should have power, but since I'm not going to really shift the board around, I don't think that will be a problem. But as you can see here, the LED, our load in this case, is off. It kind of looked like there was a glow, but that is just reflection from the light. So it is off. I press one of our inputs, it stays off. I press one of the other inputs, it stays off. And you may actually see this in practical circuits. And you may be using a power tool or something. You have to turn a key or something to turn it on for safety, and then step on a platform before it will turn on. And then like you fall off or something, or somebody turns off the key or flips a switch or whatever, the output or the load turns off. And you may do that for safety reasons or other reasons. So even the mechanical form, you may come across it, and I don't think as much anymore because everything's digital, but it is possible. It's a simple circuit, as you can see there, and there's a number of reasons why you might make a circuit like this, where you have to have two switches in the on position for the load to be on. And it's this straightforward. All you're doing is you're literally cutting off the path of current flow. And so right now the two switches are open. It's an open circuit there and an open circuit there. So it is connected from the negative rail through the power supply and then positive rail there, but then there's no path here, nothing can conduct until we close these and make a connection from that pin to that pin plus that pin to that pin. Now there's a space across there. Also with these pins, the bottom two are always connected. So this jumper, this node right here, ground there, goes all the way across here, right there. And then where we have this connected, if I connect something else here, it will connect directly to there. And here to there, and so on. So in any case, I covered, this is a pretty simple topic, so I covered extra topics, beginner electronics, in a little more detail in this one. I avoid that more on the, a bit more complicated circuits, just to get through the main point. And I covered some more of the basic stuff in case you were not aware of those already. People don't watch videos in order of difficulty or whatever, or advancement, but the basic stuff applies even to the most complex of circuits. So really learn the basic stuff. That's going to make it so you can understand the more complicated stuff. The more complicated stuff is just a whole bunch of basic stuff put together. And so in any case, hopefully you liked the video. Thanks for watching. I will see you in the next video.